Alright, welcome back to another video on my channel, math_exc. Today we're going to talk about arithmetic sequences. So this is the first type of sequence that I'm going to talk about, and then just like how you want to find the nth term of a arithmetic sequence, and also the sum of the first n terms, which I'll discuss later. So basically, arithmetic sequences is sequences that has a pattern of adding or subtracting a constant, and that constant is usually known as the common difference. And then you add that common difference to a term to get the next term. So an example of an arithmetic sequence is like so. So T1 is the first term, T2 is the second term, and so on. So notice you add by a common difference of D, D for difference, so yeah. And then this is constant for every two consecutive terms. And another like example is a sequence like 1, 4, 7, 10, and so on. And notice the common difference in this case is 3, because you add 3 to get the next term. So in this case, for 1 you add 3 to get 4, and then from 4 you add 3 to get 7, and you can do that infinitely many times. Alright, the formula for the nth term is given as this expression right here. So if Tn, the nth term, is equal to a plus n minus 1 times d. So a is T1, or the first term, and d is the common difference, just like I told you before. And for you all, in case you are wondering how did I get this formula, so something like this. So we can just rewrite a sequence T1, T2, T3, and so on, and then we can rewrite this in terms of a and d. So for T1 we just assume that it is a. For T2 it is a plus d, because we add d to get the next term. So it does make sense that T2 is a plus d. And then to get the next term, you add yet again another d. So T3 now becomes a plus 2d. And then you can just do this all over again. Okay, and you can rewrite these a plus d's as follows. So if a plus 1 minus 1d, you see y later. So if a plus 2 minus 1d, right here, and if a plus 3 minus 1d, and then we have a plus 4 minus 1d. And notice these numbers correspond to the first term. So this 1 corresponds with this 1, this 2 corresponds with this 2, this 3 corresponds with this 3, and then therefore, if the assume that we have the nth term, this n will then correspond to something like a plus, and that we replace the constant with n minus 1 and times d. So this is kind of like a, I would say, quote-unquote visual proof for this. You can kind of like just rewrite some things a bit. So yeah. So I would say that's it for finding the nth term of an arithmetic sequence. Now we're going to go to a little bit more complex thing, which is the formula for the sum of the first n terms. So Sn, which is the sum of the first n terms, is given as a half times n times in the parentheses a plus tn. A is the first term, tn is the nth term. Or you can just substitute the fact that tn is a plus n minus 1d to get something like this. So we have a half n times in the parentheses 2a plus n minus 1d, where d in this case is the difference. And a proof of this formula involves rewriting the same sum differently. So we know that addition is communicative. So we can just rewrite, assume that Sn is the sum of the first n terms in an arithmetic sequence. So the first term in this case a, second term is a plus d, just like on the previous proof, and then all the way to a plus n minus 1d. This is the nth term. However, we can just rewrite this by flipping, I would say flipping or switching the terms to like a reverse order. So in this case, we write the nth term first, and then the nth minus 1 term, and then all the way to the first term right here. And then with this, we get a very nice result. So we have Sn plus Sn, we get two of these copies, and then summing each term, we can get that we also have multiple copies of these 2a plus n minus 1d's right here. So 2a plus n minus 1d, from this we also get 2a plus n minus 1d for this as well. And you may be wondering how many 2a plus n minus 1d's are there? There are exactly n of them. Why? Because remember this, we're counting from the first term to the nth term, so there are n terms between these. So we can just rewrite this as a multiplication expression. So we have n times in the parentheses 2a plus n minus 1d. And then we're not done yet, because remember this is still equal to 2 times Sn. But we can just simply divide both sides by 2. So we have Sn is equal to a half times n times 2a plus n minus 1d, or as I said before, a half n times a plus tn, where tn is the nth term. So I would just say some special properties obtained from these two formulas. So let's just look them one by one. So if Tn is the nth term of an arithmetic sequence, and Sn is the sum of the first n terms, then Tn, the nth term, is equal to the sum of the first n terms minus the sum of the first n minus 1 terms. And you can just simply see this by extracting the definition of Sn and Tn. And then you can get that this claim is true. Alright, and the second one has something to do with d. So if d is the common difference and tn is the nth term, then d is the nth term minus the n minus 1 term. And this applies for all n in the natural numbers which are equal to or greater than 2. And this bound of inequality is important, because if you take n equals 1, you'll get t of 1 minus t of 0, and t of 0 doesn't really exist, so it doesn't really make sense. And c is the expansion of b right here. So we get something a little bit more complex. So if d equals the mth term minus the nth term, and this is over m minus n, and this applies for all m and n in the natural numbers with the criteria n must be greater than n. And I should have added that this could be equal to or greater than 1. So yeah, and you can just simply see this, that this is true, by extracting the definitions of t of n. Alright, so that's it for everything. I covered some of these complex stuff, because this video is mainly for some secondary students and probably some high school students that are learning about complex sequences, like the sum of the first n terms and stuff like that. Alright, enough talking. Let's jump into some example problems. Alright, we'll start things off very simple for the first question. So given a sequence 2, 6, 10, 14, and so on. We need to find the 20th term of the sequence, and then we need to find the sum of the first 10 terms in this sequence. Alright, let's do the A part first. Part A, first we need to find the general formula for the nth term. So Tn, we know that it is equal to A plus n minus 1 times D. And we know D is 4 because we add 4 to get the next term. So we get from 2 we get 6 by adding 2 by 4, something like that. And in this case A is 2, that is the first term, plus n minus 1, and before D is 4. We can expand this brackets, so have 2 plus n times 4, which is 4n, and 4 times negative 1 is negative 4. And then we can just simplify this to get, this is 4n minus 2. And then for the 20th term, the 200th term, sorry, this you can just substitute n equals 200. So we have 4 times 200 minus 2 is equal to, this will be 798. And I would say writing a general form for a sequence is very important in case if you need to find like a big number. So in this case a 20th term, and then you have limited time to count that manually. So writing this formula is very, very useful. So anyways, for part B, find the sum of the first 10 terms of the sequence. Alright, so we can just use our formula for Sn. Sn is equal to a half times n, times in the parentheses 2a plus n minus 1 times d. Or you can suppose you need to find the Tn, in this case the 10th term. You can just do that as well, and then you can just do that all the way. But in this case I want to save time for this. So we know A equals 2, D equals 4, and n equals 10 for this question. So S of 10, the sum of the first 10 terms is just a half times 10 times 2 times 2, A is 2 before, plus n minus 1 times 4. And I should have written 10 inside the n. Alright, the front expression will be 5, and that the inside will be 4 plus 10 minus 1 is 9 times 4, it will be 36. Okay, and this will be 5 times 40, which is equal to 200. Alright, and this is it for the first question. Let's jump into the next one. Question 2 has something to do with dot patterns. So observe the dot pattern below. So pattern 1 like so, pattern 2 like so, pattern 3 like so, and pattern 4 and so on. So I want to draw the 5th pattern of this. And then we can analyze the dot pattern by noticing the length of this, the vertical and the horizontal length of this, whatever this pattern is. So notice for the first pattern, the length is 1 and 1. For 2, the length is 2 and 2. 3 is 3 and 3. And then you can just see where this is going. So immediately we can just draw the 5th pattern. So the 5th pattern will look like this. So 5 dots horizontal and 5 dots vertical. There you go, something like that. And then I would just label this as pattern 5. So for part B, by writing a formula for the number of dots, find the number of dots in pattern 56. And in fact, these dots, the total number of dots in each pattern actually forms a arithmetic sequence. So notice the number of dots for pattern 1 is 1, and number of dots for pattern 2 is 3, and then 5, and then 7, and so on. And in this case, A is 1, that's the first term. D is 2 because we add 2 to get the next term. And therefore, we can just write a general form for the number of dots in the nth pattern. So we call our formula for the nth term of an arithmetic sequence. We have A plus n minus 1 times D. So we have 1 plus n minus 1 times 2. Expanding this, we get 1 plus 2n minus 2, or 2n minus 1. Alright, what this is asking, the number of dots in pattern 56. So pattern 56, we can just substitute n equals 56. So we have t of 56 is equal to 2 times 56 minus 1. This will become 112, and therefore this will be 111. Pretty nice that this ends with 111. And okay, for the C part, we need to find the total number of dots for the first 12. This is a typo. This is supposed to be a pattern. Okay, since we know the dots actually form a arithmetic sequence, you can just directly use the formula for the sum of the first n terms in a arithmetic sequence. So we call it as half times n times 2a plus n minus 1 times d, or a plus tn if you want. However, for a plus tn, you need to manually count to manually find what tn is, and then you can just use the formula straight away. So for this formula, we have s of 10, the first 10 terms is a half times 10. Oh wait, sorry, it is 12 patterns, not 10. And this is multiplied by, we know a is 1, n is 12, and d is 2. Yep, double checking, there we go. The front expression will become 6, the inside will become 2 plus this will be 11 times 2, that will be 22. This will become 6 times 24, or this will be equal to 144. Okay, so this is it for the second example. And now go to example 3. Alright, for question 3, this is a type of word problem. There are 10 rows of seats in a theater. In row 1 there are 30 seats, in row 2 there are 32 seats, and this pattern goes on and on until the 10th row. We need to find the number of seats in row 10 and the total number of seats in the theater. Alright, we can just write the sequence. So in row 1, in this case I would just call it T1 for term 1, the first term, let's say. So I have 30, 32, 34, and then you can probably guess the next term will be 36, and so on. Notice D is equal to 2, write this right here, and then A is equal to 30. So the first term is 30, the common difference is 2. Therefore, we can just write a general form for the number of seats in the nth row, which is just a plus n minus 1 times d. plugging in a and d is 30 plus n minus 1 times 2. We have 30 plus expanding this and finally getting an answer like so. Alright, we need to find the number of seeds in row 10. So we can just substitute that n equals 10. So if t of 10 is equal to 2 times 10 plus 28, this thing will become 20. The whole thing becomes 48. There are 48 seats in row 10. And we need to find the total number of seats in the theater. So in this case, it will be S10, since there are 10 rows, and we need to find the sum of the first 10 rows of the of seats in the theater. Alright, so S10 will be just a half times n. However, n is in this case is 10, and then multiply this 2 times a. We know a is 30, plus n minus 1, which is just 10 minus 1, multiplied by d, which is just 2. Yep. Or perhaps in this case I'll just do the easy way using the a plus t formula, a plus t of n. So we know the first term, which is 30, and then we know the 10th term, which is 48. The front will become 5, the inside will become 78. And then calculating this, you will get that this will be equal to 390. So there are a total of 390 seats in the theater. However, you can just do the 2a plus n minus 1 times d type of the sum, and just any way you want, as long as you didn't miscalculate some stuff. So yeah. Anyways, there will be one more example of this type of questions. Alright, for the last one, it is pretty interesting. So instead of we're given the sequence, we're actually given the formula. So in this case, it is known that the formula is t of n is equal to 10 minus 4 in parentheses and n minus 1. And based on the formula given, write the first 3 terms. So we need to write t1, t2, and t3. So that's pretty simple. We just write t1, substituting n equals 1. We get 10 minus 4 times 1 minus 1, which is 0. And the whole thing that's subtracting that is 0, so it's just 10. T minus t of 2 in the other hand, it will become 10 minus 4, the inside will be 2 minus 1. This whole thing will be negative 4, and the second term will be positive 6. And finally, the third term, and just mark this as part A. The third term will be 10 minus 4, 3 minus 1. This whole thing will be negative 4 times 2, which is negative 8, and this whole thing will become 2. And then the common difference in this case is negative 4, because you subtract by 4 to get the next term. So you get 6 obtained by 10 minus 4, 2 obtained by 6 minus 4, and so on. Alright, and then the part B is pretty interesting. Hence, find m if t of m is negative 86. So we're given the formula. We can just solve this real quick. So t of m is equal to 10 minus 4 in parentheses m minus 1. or you can just expand this to get 10 minus 4m. Negative 4 times negative 1 will be positive 4. This will be negative 4m plus 14. Alright, we know that Tm is negative 86, so we can just straight up plugging that in. And then we can just do some linear equation stuff. Subtracting by 14 on both sides, so that will cross this out. We get our left hand side will become negative 100 equals negative 4 times m. And then we can just straight up divide both sides by negative 4 to cancel this part, to get that m is equal to positive 25. There we go. So this is our answer, and that finishes our video for this. And hopefully you guys enjoy this video. Please subscribe for more videos, and I'll see you guys in the next one. Goodbye.